Let us look at minimum and maximum values of a function. Let us say we have this quadratic function. This is x squared minus 3x minus 1. Now, here, this is a quadratic function that we have. Now, we have various values of x and other values of f of x. Now, what we have here, when we have x is equal to -1, then f of x would be equal to, it seems like 2 here. When x is equal to -0.5, f of x is, it seems like about 0.6. When x is equal to, say, 0, x is -1. When x is equal to 1, x is -3, and so on and so forth. When x is equal to 2, f of x is also equal to -3. But somewhere between 1 and 2, the function goes lower to the minimum, right at the bottom of the valley, and then it starts to rise again. So if you should move, if you should try to walk or climb down this hill, right? You're climbing down because you want to get somewhere over here, over to the right. So you're climbing down the hill and you reach the bottom of this valley here and start climbing back uphill. You reach a point where you're at the minimum point. That is the lowest point. Alright? You're at the lowest point that you can reach. Let's use a line to see how we can indicate the lowest point. In fact, let's also make our curve and line thicker than they are right now, so you'll be able to see them more clearly. All right. I want this line to be very thick. Good. This curve, this is a point. All right. Right along the curve, and you see as you go down, there's a lowest point that you reach, and then you start going up. Now, my straight line is this. Let me make it a bit thicker as well, and I want the color. Let's make the color blue. If I move my line just to touch the bottom of the curve, then right here on the f of x axis or the y-axis, I can read off what the minimum value is. So this is a minimum value because the values, as x goes from left to right, the values of f of x change. They keep changing. But f of x falls down, and when it reaches close to about 1.5, it reaches the bottom of that valley and start to go back up. The lowest point is the minimum point. Now, let's do some adjustment to this function. As we can see, this is a quadratic function where whenever you have the coefficient of x squared negative, now you get a maximum value instead of a minimum value. Now we have a maximum value, right? If you should move along this curve, you're going from left to right with x. You see that when x was negative 3, f of x was about negative 1, right? When x is 2.5, f of x seemed to be 0.2 or something. When x is negative 2, right? Here is negative 2, you go up to the curve, you project towards, horizontally towards the f of x axis, f of x was 1. But what you find is that as you have x moving to the right, the corresponding values of f of x are rising up the hill, and then it reaches the peak, the highest point on this curve. This looks like a hill, and on the other side you start going back downhill. So the highest point is the maximum point. And of course, you can identify that point or estimate where it is using the graph by drawing a horizontal line that touches the curve right at the tip there and going across to the f of x or the y-axis. This seems like it could be probably 1.7 something, or probably 1.6 or so. All right, no, it wouldn't be 1.6 nor 1.7. 1.5 is here, so it could be 1.2, 1.3, somewhere about that. All right, now you have a maximum point because all the other points, all the other values are lower than that value. And just as in the case of the maximum value or the minimum value, you have a minimum value right down here that you can estimate by projecting across to the f of x axis, right across. You have values on the curve for f of x that correspond with each value of x. From the left, it's going down, 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 down. These values on the f of x axis drop and they reach the lowest point, and then they start to rise again. All right, so these are the maximum and minimum values, and this is called a quadratic curve. These values get lower and lower till it reaches right here, and then start to get higher and higher. So the lowest value is the minimum value. Now this is a quadratic function. Suppose we have a cubic function. Let's say x is raised to the power of 3. All right, so this is a function x cubed minus 3x minus 1. Now you have a value here that kind of looks like our earlier maximum value, right here, because if you should consider the x at negative 2, f of x is about negative 3, but at negative 1.5, f of x rises up to 0. At negative 1.3 or so, f of x is still higher. It keeps rising. 1.3 is probably about here or so. So the value of f of x, when you project towards the curve, and then I'm trying to make this a straight line, you go to the right and you can see your f of x value right here, whatever it is. All right, so here now you have this value right here, that looks like the maximum value that we saw earlier. However, that is not the maximum value of this curve, because you have values higher than it. Also, you consider the minimum value, what you have happening right here, right within this region. It looks very much like the minimum value of the quadratic equation that we've seen before, but the thing is, this is not the minimum value. That's because there are values that are lower than it. No, there's a name given to it. What you say is, within this region, you do have a maximum value, and within this region, you do have a minimum value. Now, these are called local. This is a local maximum because it's just maximum within a certain range of values for the graph. But there are values that are higher than it. So this now, let me put my blue line there. This value here is not the maximum value for this curve, because there are other values that are higher than it. But the thing is, within this region here, I could extend it to an even wider region, right? This is a maximum, so you call this a local maximum. It's not an overall maximum, it's a local maximum. As for this now, this is a minimum value, but it's a minimum value only if you concentrate on a part of the curve. If you go outside of that part of the curve, it's no longer minimum, because here it would line up with this, but there are other values that are lower than this, so this is not an overall minimum value, but it is a local minimum. When you consider the region within here, it's a local minimum value. All right, so we're going to continue looking at this and other lessons in further videos, so I will see you then.